Good morning, everyone, and welcome to today's presentation for Module 28. Before we jump into that module, I wanted to go ahead and cover a couple of key takeaways for Module 27. The first being that the natural distribution of water does not always suit human needs, and so human beings have gotten really good at coming up with huge, large-scale infrastructure building to divert water and to store water. And then also, as we move forward and we're facing an increase in human population, human beings around the globe are going to really need to look for and practice conservation efforts that could lead to more sustainable use of water. Second, here we have levees, dikes, dams, and other water-related infrastructure. While they can be helpful, remember that they come with extremely high startup costs, high maintenance for the years that they are present and working. There tends to be consequences for local ecosystems and the soil health of those ecosystems. And there always seems to be increased controversy surrounding water ownership and who has what rights to the water and how to divert the water or use the water. Next, we have large-scale water diversion projects. I wanted to remind you that it is worth you knowing some of these ecosystem-related, concerns and case studies. For example, the Aral Sea. What happened with the Aral Sea? It's worth you investigating the Three Gorges River Dam in China and the outcome and controversy of that. So just kind of a warning and caution there. And then lastly, that desalination projects, they require lots of energy. Remember, there's the heating element for the distillation process. There's high costs and maintenance involved with those projects also. And don't forget that both distillation and desalination produce brine, the brine problem. Okay, I'm going to jump into Module 28, which is human use of water now and in the future. We're going to take a look at the 4 methods of agricultural irrigation to describe the major industrial and household uses of water, and to take a look at water ownership and water conservation and how important they are in determining future water availability. Remember, we're keeping an eye on human population growth over the next several years. So basically, everybody has a water footprint. That's the daily use of fresh water per person around the globe. And for the most part, fresh water is mostly used for agriculture. So agriculture in creating crops, crops being created to feed the billions on our planet. And you must know by now that water use per capita can vary dramatically among the nations of the world. If we take a look at this next slide, it shows various countries of the world, and as we can assume, the United States and Canada, are using the greatest amounts of water per year. Over here, we have a lot of water usage. You should know that this is also very much like the interior of the United States. This area here produces a lot of agriculture for these people in this region of the world. So lots of agriculture output here. Australia is very high at using water per person. India, down here in South America, we have some more. And then I'm going to draw your attention to those areas that are extremely scarce in water availability. So that means water usage would be very low also. The interior of Africa, it's pretty alarming to see how little water they have and use. So this next slide takes us into the 4 different types of irrigation. We have furrow irrigation, flood irrigation, we have spray irrigation, and drip irrigation. They all come with their water efficiencies, water use efficiency. So the oldest irrigation methods would be the furrow trench method, and that can be seen in this picture here, where basically farmers will dig these furrows next to the plants that are being grown, and then they'll flood those furrows, and the water will then reach, as you can see as it moves down the row here, it'll reach into the roots of those plants that are being grown in the area. Furrow irrigation is the oldest method, and it's about 65% efficient. So it's probably the lowest in terms of efficiency when we're looking at all of these irrigation methods. The next one is going to be flood irrigation. So basically, you'll have your land, agricultural area. The farmer will just flood the entire area. So here, water just goes everywhere. This is while effective at watering the plants. There's a lot of evaporation involved in flood irrigation, and it's about 70 to 80% efficient. You also need to know that sometimes plants can have, when they have wet feet, which means that they've been exposed to water for too long, sometimes they die. So this type of irrigation can actually cause problems for plant growth. The next one is spray irrigation, and that can be seen here. And as you can see, the water is just shot out of these tubes. Greater distances, but as you can imagine, there's a lot of water loss, lots of evaporation involved, and not a lot of direct contact with the plants per se. Spray irrigation, while very popular, is about 75 to 97% efficient, but again, there is the potential for water loss. And then the last one, which is most efficient, is going to be drip irrigation. Some of you might have this kind of system set up in your homes, your backyards, and feeding the plants in your area. It is considered the highest in efficiency at 95%, and the reason being is because, as you can see, the drip sits right next to the plant. And so the plant is receiving directly the water that it needs, and there is no extra water being lost in that process. Another option is hydroponic agriculture, and this is gaining in popularity. It does cost a lot of money to raise food and plants this way, but basically in this diagram up here you can see there's no soil involved. So basically the plants are hung above, and they're kind of sitting in a nutrient solution that then runs underneath their root systems and being fed by way of a drip system above. And so it's very direct, very successful, efficient, as you can imagine, and the other plus is that it doesn't require soil. And because of that, crops can also be grown year-round, so we can have food production on a more consistent basis this way. Uses up to 95% less water than traditional irrigation, but like I said, for many parts of the world, it's coming up with the money to convert their practices to this particular method. So there's cost involved, a lot of life changes involved. It's not that easy to switch over. This next slide, we start to get into industrial versus household use of water. And as I mentioned earlier, agriculture across the world is the greatest user of fresh water, which makes sense because we're feeding a lot of people. But the other one is water for industry and household. And so in terms of industry, you might not, it doesn't necessarily, make a lot of sense right at first, but industrial use of water is very, very high. To generate electricity in the United States, that's where more than half of all of our freshwater usage goes. And that's to turn on the lights, run your hairdryer, perhaps your electrical vehicle. Very soon here, we're coming into Christmas, so we're going to be plugging in to light up all those Christmas lights. A lot of water is used in generating electricity, and it's because a lot of electricity is produced via steam-powered plants. So water is basically boiled to produce steam. The steam is used to turn a turbine, and the turbine, which is magnetized, as it starts to rotate, is where the electricity generation comes from. But it all begins with the heating and the production of steam water. Cooling machinery, just like in your cars, we have to have water in our radiators because it's used to cool the engine. Think of that on a very large industrial scale, lots of water being used to cool the machinery so that it can continue working properly. When we create metals and we remove metals from ore and other mining processes, an example would be the creation of copper wiring, which is still the primary wiring that is used to build buildings and homes. It takes a lot of water to produce that type of product. And then the last one here is making paper. It's good that we use Schoology like we do, and we use digital forms of submission and evidence of work because making paper requires a huge amount of water. And so when your mail comes in, some conservation possibilities with each of these would be use that junk mail that comes in the mail. Use that as your grocery shopping list, or what you're going to take some notes on for a class. You can get pretty creative there. Copper wiring, we got to make sure that we recycle it when we're done using it. Not so much control over cooling machinery, but we have a lot of control over the amount of electricity that we use. So unplug those devices at home, appliances at home that don't need to be plugged in. Remember, even when they're not operating, they could still be drawing electricity. They're called phantom outlets. And with that is a lot of misused electricity. So unplug is the answer. The next one here is household water use, and so you can see here, according to the pie chart, there is a lot of water being used in our homes. I want you to think about this when looking at the pie chart. Where in the house is the most water used? And then you need to know that, again, per capita use of household water is going to vary across the globe just based on different socioeconomic statuses, whether or not a country has access to energy conserving devices such as toilets, low flush toilets, not energy conserving, water conserving, but water conserving, attributes such as low flow toilets, low water use, washing machines, and dishwashers. Not all countries have access to those types of appliances. So per capita household water use can vary based just on that fact alone. Here we have a slide that shares, Australia, bad Australians, they're using a lot of water, over 900 liters per person, and this is per year. And down here in Kenya, as you can imagine, we looked at that map earlier of Central Africa and other parts of Africa, very little household water use because they just don't have the same access. Some ways that we can conserve water. There's tiered water pricing systems. So the more you use, the higher you get charged. PG&E actually does that for energy production. And water the same. The more you use, the higher the amounts that you have to pay. Your family can look into xeriscaping, which is a type of landscaping that's going to remove high water drinking plants in place of those types of species that are more native and more water efficient. That actual process can save you lots and lots of gallons of water use. And then I have linked here, and we can look at this afterwards, but Contra Costa Water District actually offers a rebate to families and owners of houses to convert their lawns to more water efficient landscaping, and they'll actually give you money back because of that. So lots of different municipal companies and so forth are looking for ways to help with water conservation, and this just happens to be Contra Costa Water District's method for helping to save water. And then this last slide here is the future availability of water and how it depends on water ownership and water conservation. There are lots of issues worldwide over water ownership and water rights with lots of conflicts. We talked about the Three River Gorge Dam. We talked about the Aral Sea, and you can read those last two on your own.